In this question, we are given that n is an integer. We have to find the greatest common divisor or the GCD of 12 and n. Now this can be written as GCD of 2 squared multiplied by 3 and n. Now to find the GCD, we have to look out for two things. First would be to note down the common primes, and the second would be to consider the lowest powers. Now we move on to step 2. Let's analyze statement 1 first. In the statement 1, we are given that the product of 12 and n is equal to 432. Now the value of n can be found out by dividing 432 by 12, which gives us 36. And when we substitute the value of n, we can find the GCD of 12 and 36 and get a value. Not need to calculate it since we have to check the sufficiency of the statement. Hence, we can say that statement 1 is sufficient. And out of the given options, we can eliminate options B, C and E. We now move on to check the sufficiency of statement 2. In statement 2, we are given that the greatest common divisor or the GCD of 24 and n is equal to 12. Again, let's write down 24 as 2 to the power 3 multiplied by 3, n. And let's prime factorize 12 as well. Then 12 can be written as 2 squared multiplied by 3. This means that the common prime numbers between 2 cube multiplied by 3, that is 24 and n, is 2 and 3 only. Now you may end up making a mistake after concluding that since the value of n cannot be found from this, we cannot find the GCD. But this is a seed trap. Let's understand how to find the value of the GCD. Now, since we know that the value of the GCD has 2 and 3 as prime factors, then the value of n will be a bare minimum of 2 squared multiplied by 3. N cannot be equal to 2 cube multiplied by 3 because in this case, then the GCD of 2 cube multiplied by 3 and 2 cube multiplied by 3 would be equal to 2 cube multiplied by 3, which gives us 20. The statement states that the GCD is 12. So the value of 2 cannot be 3. Hence the maximum value of 2 should be 2. Also the power of 3 can be 1 or 2 as well, because if the power of n is suppose 2 squared multiplied by 3 into 3 squared, GCD would still be 2 squared multiplied by 3 since we have to check for the lowest powers. We can also assume that the value of n can be 2 squared multiplied by 3 and we can get some other integer as well, where the value of k can be equal to 5 or 7 or any other prime numbers. In that case as well, when we find the GCD of 24 and n, which is 2 squared multiplied by 3 multiplied by k, since we have to look for common primes, the common primes will be 2 and 3 and the lowest powers would be square of 2 and 3 to the power 1, which gives us 12. Using this logic, we can find the GCD of 12 and n, because when we write 12 as 2 squared multiplied by 3 and n as 2 squared multiplied by 3 into k, this will give us 2 squared into 3, which is equal to 12. Thus we are able to find the value of the GCD, and hence we conclude that statement 2 is sufficient. So the correct answer is option D.